distributed compute engine, so it distributed query, and that's why they need plan. So the metadata, as you know, metadata means data about data. So what in BigQuery metadata store the meta about the data sets. So metadata basically store about data set, table, and queries in the distributed meta store called the capacitor. The capacitor provide a centralized view of metadata, which allow easy management of dataset and tables. The next part is security. It's very, very important for any kind of the data warehousing. So BigQuery provide a multiple layer of security to protect data. It's very important nowadays. It's support encryption data, both transit and rest. It provide a fine-grained access control using IAM role and permission. Integration. Integrate means other tools, how you connect with other tools. So BigQuery provide the integration with the Google Cloud service such as Cloud Dataflow, Cloud Data Proc, Cloud Composer to enable user to process and transfer data before storing in a BigQuery. Overall, BigQuery architecture allow you to handle large datasets, execute complex query efficiently while providing robust security and easy integration with Google Cloud. So now let's talk about a little bit about BigQuery, how it works. Part of the third wave, cloud computing, which and Google Big Data Stack 2.0 focus on serverless compute, real-time insight, machine learning. Instead of data placement, cluster configuration, no managing infrastructure. So the story started in 2002. We started GFS, and in 24 map reduced. Then 25 is big table, 26 is a Dremel, and here the BigQuery came in the picture. And after 2000, PubSub came 2010 and 2000. So this is a global name, and this one the Google Cloud name. You can Google a Cloud with 2.0. This is Google Cloud. So this is starting from 2.0. So Google Cloud BigQuery is fully managed, as I said, and data warehouse that enable user to store, analyze, and large data set in a cloud. So it's BigQuery work data. Sorry. So data injection, BigQuery allow user to inject data from a variety of sources, including Google Cloud Storage, Cloud SQL, other third-party data storage. Data can be in a variety of formats, including CSV, JSON, Arrow, and more. Data storage, as I said, it choose Google Cloud Storage. This storage format is optimized, analytic, and query and enabling. Query execution, we just talk about plan. Data analytics, BigQuery provide familiar SQL interface user for perform a query, create view, join tables, also support advanced functions such as machine learning and geospatial function. Data visualization is also support Google Data Studio, Tableau, Looker. This is integration enable scalability, which we talk seamlessly handle petabyte of data processing complex. Cost effective means whatever you use, you need to pay. Overall, simply process storing data, analyze large data sets, enabling user to gain valuable insight. Okay, BigQuery overview is talking. So how BigQuery work? Job query can scale up to thousands of CPU across the many nodes, but the process is completely invisible and user store the compute separate connected to performance. So end user don't need to understand more, but behind the scenes it works like this. How BigQuery works? So this is my previous columnar data store. So BigQuery data is record oriented storage columnar. So this one column, but in row wise, I mean every row store. This is columnar database. And BigQuery structured data sets contain table and view. Table is a collection of columns. Jobs is a long running action query. Identify access control. So which is called IAM. So control. So this will go to pricing is also very cheap. So you see the price 0.02, 0.2 cent per GB per month. First 10 GB is free. Long-term storage not edited by 90 days is 0.01. It's less than half of this price. Query $5 per 1 TB. First TB is no more. First month free. Streaming 0.01 and 200 MB. Streaming is expensive. Pay as you go with high and flat rate query pricing. Flat rate start with 40K per month and 200 slots. Integration is there are various integration: web UI, command line, programmatic REST API, interacting by query, querying table, just like simple SQL, Legacy SQL is a from tables. Searching multiple tables with a wildcard also is possible. Google Cloud provides several ways of interacting with the data storage. Here are some of the web UI. BigQuery offers web-based interface. Allow user to explore query data using visual interface. It's a simple way to run ad hoc queries, browse table schema, preview data, and manage query. Command line tool. BigQuery also provides command line tool called BigQ. It allows to user to manage datasets, tables, jobs, and busy. REST API. BigQuery provides REST API that allow user to programmatically interact with the service. API can be used for manage client library. BigQuery provides a client library several programming languages including Python, Java, and Go. These libraries simply process interacting with a BigQuery by providing easy to use interaction handling. Integration, as I talk, it can integrate with the Data Studio, Tableau, and Looker. Load and export is very simple, like loading, exporting, importing data. So cloud storage, local PC, then BigQuery is here, streaming cloud data flow is here, streaming insert here, BigQuery is here, cloud bigtable is here, cloud drive is here, cloud storage. So everything is interacting with BigQuery. So load will CSV JSON Avro basic compressed file Parquet datasets. Read for CSV JSON Avro Parquet. So these are the format supported. Why the external sources? There is also external means from outside, internal also inside. Google Cloud BigQuery provides several ways to load and export data. Load data. BigQuery allow use to data load from various sources, including Google Cloud Storage, Google Drive, third-party sources. User can load data several formats, including CSV, JSON, Avro, Parquet. So these my previous lecture. You can watch what is difference between JSON, Avro, and Parquet. So there are some JSON formats and some Parquet format. Some is columnar for JSON. So Avro is best for compression file techniques. This is the steps: create dataset BigQuery table and load data uploads. And this is very simple. You can see this some example. I will not go through into details. And this is also the next part in my part. Export table can only export cloud storage, can only copy table. Another big data exporting format. It can export multiple tables with command line. Can only export 1 GB per file, but can split in multiple file wildcards. There are techniques. Optimize performance cost. Less work, faster query, less cost. So less work equal to faster query, less cost. So you need to optimize query. What is IO? How many bytes reads? Input output means how many byte reads. Shuffles means how much goes to next stage, right? These are very important terms. How many bytes written? CPU work in function. General best practices: avoid using select star. Demonstrate data when possible. Group data into single table, often with the nested and repeated data. Good for read performance, not for write. Filter early big with where clause. Do biggest join first and filter free join. Limit does not affect cost. Partition data by date. Partition by insert time. Partition specific data code. These are some best practices you need to do. Optimizer is so let's talk about some columnar storage. So some Google Cloud BigQuery Optimize is a critical component. It's a performance and cost efficiency. The optimizer automatically tune the query execution plan based on the size of data, the structure of query, and the resources available to execute query. Here are some way to optimize query. So the first is a columnar database. BigQuery store data in columnar format, which is optimized analytic query. Columnar storage allow faster scan times and reduce amount of data need to be read from disk, resulting faster query processing. Query parallelism. BigQuery distributed query across multiple nodes, allowing to parallel execution query tasks. Parallelism is improve the query performance and reduce. So you also need to do query parallelism. Columnar storage. Query optimization. BigQuery automatically optimize the execution plan based on size of data, the structure of the query, and the resources available execution of query. The optimizer determines the most efficient way to execute a query, minimize the amount of data. Resource allocation. BigQuery allow user to allocate resource, query, CPU, and memory. Allocating resource can be improve the query performance by ensuring that query has enough resource to compute. Cost control. BigQuery is pricing model based amount of data processed, or allowing user to control cost by minimizing amount of data scan. User can optimize query by using filter, aggregation, and other techniques to reduce amount of data scan which can result. So there are several techniques. First, I would like to say you just filter data. Whatever you need, you just filter only those data. Don't compute again, same compute you can store. So this is the some plan, monitoring query performance, waiting, reading, compute, write, parallel input, and you can see the which one is taking more cost. Input, collage, join, aggregation. Here you see the join took the more compute. Here output took more time. Here read took more time. Here waiting also more time. So sure, how to perform streaming into BigQuery. So Google Cloud.import BigQuery, client BigQuery, client connected, dataset, client data sets, then table name, column one row, I created row, then insert row, client insert row, then insert. So this is how to row is inserted. Query logging and monitoring. So the query logging and monitoring, there is a called stack driver monitoring and logging difference. Monitoring is performance resources, logging is who is doing what, history of action. Monitoring BigQuery performance resource, monitoring metrics performance resource, stack driving. There are many cloud BigQuery provide several logging and monitoring tool also. Cloud logging allow user to view and analyze logs generally by BigQuery resources. User can create and custom logs. BigQuery monitoring use real-time performance metric inside of BigQuery uses. User can monitor query performance, view active connection, and track resources uses. BigQuery monitoring, and this is cloud logging. Stack driver trace provide the capability of BigQuery, allowing user to trace the execution individual query and identify performance bottleneck. BigQuery audit logs, there is log, stack driver monitoring. So these are the logs which you need to see how the BigQuery is performing. Data format, best performance is Avro format, so which is the scenario input multi-TB data. So Avro compress, Avro and for Parquet, CSV compress, JSON compress. So Avro can compress. So best is this one. You need to check which one is. What is partition table? Specific segment table divided segment into the partition. Why this is query is only certain row partition. Limit amount of read, improve the performance, reduce the cost. Partition type, ingest type when the data row is created. Include timestamp and date column scenario. You know the like date everyday create. Some of the common best practices for Google Cloud Query. First, you need to in a columnar database you need to design first schema. Right, your requirement and schema, then the properly design schema significant impact the query performance cost. It is important to design a schema, minimize amount of data process and avoid unnecessary join. Partitioning can help to improve performance, allowing to focus a specific range of data. I mean, it will reduce your filter data. Clustering also improve query performance by grouping data together based on a specific column. Clustering can help reduce the amount of data scan and speed of query. Data compression. BigQuery automatically compress the data by save the storage space and reduce cost. However, user can further optimize query performance by choosing appropriate compression option. Data loading. Loading data BigQuery can impact performance and cost. Appropriate loading method we should use. Query optimization. Also, there is some filter and resource allocation. These are I already talked. And common error in BigQuery. So one of the I work in the data side last 10 years. The common is a query timeout. So this is common data loading error, some data type issue, access and permission issue, resource exhaust error, billing error. So these are the common errors which you can talk. So there is some interview question which you can practice, pause and video and watch. What is a Google Cloud BigQuery and how it works? So you can say it's a fully managed cloud native data warehouse, and it use basically three things: SQL, data analyze, and visualize. BigQuery handle data partitioning and clustering. How to optimize query performance, which I talk. How to big difference in security access control. What is some use cases of BigQuery? So BigQuery can be used variety of data analyze, processing, including the business intelligence analyze, machine learning. How does BigQuery handle data import and export? This one also you can explain. So please like and subscribe my channel. and so that I can create a valuable video for you guys. Thank you for watching.